Welcome back. In this lecture, we will investigate the energy balance of buildings. Increasing your understanding of the energy balance is a first step in identifying options to reduce the energy consumption and hence CO2 emissions from buildings. In this lecture, we will therefore identify the most important energy flows in buildings and discuss factors determining the magnitude of these flows. We take this home to analyze the energy balance for a building, and we will investigate energy flows related to transmission, ventilation and infiltration, solar gains, and internal gains. Once we know the size of these energy flows, we can calculate the required amount of heating and cooling that needs to be produced for a home to be comfortably warm or cool. We will now discuss these flows one by one. Transmission losses arise from the simple fact that there is a temperature difference between the inside and the outside of a building. In countries with a cold climate, there will always be an energy flow from the warm indoor to the cooler outdoor air. This picture illustrates winter conditions with an outside temperature of -5 degrees Celsius and an inside temperature of 20 degrees Celsius. This results in energy escaping through the roof, windows, doors, walls, and the floor. The amount of heat losses is dependent upon two factors. One, climate conditions, meaning the difference between the indoor and outdoor temperature, but also the wind speed. And two, building characteristics, like the wall and roof construction and applied insulation levels. In warm climates, the opposite is true. There will be an energy flow from the warm outdoor to the colder inside, and this will warm up the cool indoor air. How much heat enters the building is again dependent upon climate conditions, the temperature difference between inside and outside, but also on how well the building envelope is insulated to trap the cool air inside and keep the warm air outside. The second energy flow is ventilation and infiltration losses and gains. This is the amount of energy that passes the building envelope through air exchanges. This slide pictures again winter conditions with an outside temperature of -5 degrees Celsius and an indoor temperature which is higher than the outside temperature. When outside air enters the building, it will cool the building down. Warm air leaves the building and heat gets lost. In hot climates, again the opposite is true. Hot outside air will enter the building and warms the indoor air. Cool air from the inside will leave the building. How much heat you gain or lose due to ventilation and infiltration is not only dependent upon the temperature difference between the inside and outside, but also on the size of these airflows. The third energy flow is the solar gains. This is the solar radiation that penetrates the building through the windows and which is captured by the walls, roof of a building. This results in a rise of the indoor temperature. What you need to remember is that solar radiation through the windows are the most important source of heat gains in buildings. Finally, we have the internal heat gains. This is heat which is generated inside the building due to the presence of people in the building. As you might have noticed, if you are with many people in a room, the room will heat up very quickly. The reason for this is that one resting person produces approximately 100 watts of heat, while a very active person can produce up to 500 watts of heat. Next, electronics and appliances contribute to internal heat gains. You might have noticed that the refrigerator's ventilator on the back produces warm air and that your laptop becomes warm after using it intensively. These are internal heat gains that enter the room and affect the indoor temperature. Finally, internal heat gains result from artificial lighting in a building. The amount of heat produced depends on the type of lighting and the number of hours it is illuminating the room. Now that we have covered all energy flows in a building, let's see how this all sums up. In other words, what does the energy balance for a building look like now that we have analyzed the different energy flows, and what does this tell us about the energy consumption of a building? This picture shows the annual energy balance for a badly insulated residential building in a cold climate. On the left-hand side, we first list the sources of heat losses. These include transmission losses through the walls, the roof, the floor, the windows, and the ventilation and infiltration losses. We see that in poorly insulated buildings, transmission losses contribute to the major share of energy losses of the building. On the other side of the balance, we listed the heating gains, which include solar gains and the internal heat gains. What you can observe is that for a poorly insulated residential building to be comfortable, a substantial amount of heat needs to be produced. Please note that this picture can look quite different when you investigate a well-insulated building. Now let's see what this picture looks like for a badly insulated building in a hot climate. On the left-hand side, you again see the heat gains in a hot climate. These include heat transmissions through the walls, the roof, the floor, the window, and through ventilation and internal gains, and finally solar gains. To compensate for these heat gains and keep the building comfortably cool, the only solution is to generate cool air using cooling equipment. Thank you for watching this video. In the next video, you will learn about options to reduce the energy consumption by building by minimizing transmission losses.